If two non-vertical lines are parallel, then their slopes are equal, meaning if you have two lines that are not vertical with the same slope, then they are parallel. In the same token, if you have two lines that have different y-intercepts with the same slope, they are also parallel. Also know that both vertical lines are parallel to vertical lines and horizontal lines are parallel to horizontal lines. The first thing that we're going to do is look at the graph. Are the two lines parallel? Well, you could find the slope of each line by subtracting y2 minus y1 from x2 minus x1 of each of the lines, or you could just count slope. The first line has the ordered pairs -4, 1, -5, -2. The second line has the ordered pairs (5, 3) and 3, -3. I'm going to remind you how to calculate slope using y2 minus y1 over x2 minus x1. But again, you could just count the slope from one point to the next on these two lines. The slope for line 1, remember, y2 minus y1 is 1 plus 2, because minus a negative is a positive, over -4 plus 5. 1 plus 2 is 3, and -4 plus 5 is 1. So the slope of line 1 is 3. Now let's calculate the slope of line 2. The slope of line 2 is the ordered pairs 3 plus 3 over 5 minus 3. 3 plus 3 is 6. 5 minus 3 is 2. 6 over 2 reduces to 3 over 1. So line 1 is, in fact, parallel to line 2. All right, let's look at example 2. Is line AB parallel to line CD? Again, I'm going to use the y2 minus y1 formula. So the slope of line AB is 1 minus 3 over -5 minus 1. 1 minus 3 is -2, and -5 minus 1 is -6. -2 over -6 reduces to 1/3. The slope of CD is -2 minus 2 over -4 minus 4. -2 minus 2 is -4. -4 minus 4 is -8. That reduces to 1/2. 1/3 is not equal to 1/2. They do not have the same slope, so they are not parallel. I'm just going to put a slash through my parallel symbol to show that line AB is not parallel to line CD. All right, I'll do one of the examples below, and I'm going to do example 4. Really quick, if you look at example 3, you're trying to decide if those two equations represent lines that are parallel. Example 3 is pretty easy. You can see that both of those lines have a slope of 3. So yes, those are parallel. Looking at example 4, I have two equations. 3x minus 4y equals 12, and the equation y equals 4/3 x minus 5. I can see that on the second equation, the slope is 4/3 because it's already solved for y. The first equation needs to be written in the form y equals mx plus b. So that's what we're going to do first. 3x minus 4y equals 12. To get y all by itself, the first thing I must do is subtract 3x from both sides. I then have negative 4y equals negative 3x plus 12. And then I need to divide every single term by negative 4. Dividing everything by negative 4, I find out that y equals 3/4 x minus 3. I'm interested in the 3/4 term attached to the x. That tells me that the slope of this line is 3/4. These two lines are not parallel because their slopes are not the same. All right, let's graph an equation. And let's first of all find an equation of a line that's parallel to y equals 3/2 x plus 1, but passes through the point 4, 1. So we're going to write an equation of a parallel line. The first thing that we need to do here is calculate this. The first thing that we need to do is find b. We need to write an equation modeling y equals mx plus b. So we see with the first equation, y equals 3/2 x, that the slope is 3/2. Remember that if the lines are parallel, they will have the same slope. So we're going to use the 3/2 as our slope for the new line. And we know that the new line passes through the points 4 and 1. Using the coordinates 4 for x and 1 for y, we will substitute those in to solve for b. All right, so here we go. Y equals mx plus b. I know that m is 3/2. So I'm going to substitute 3/2 in for m. I'm going to use 4 to replace my x and 1 to replace my y. This will let me solve for b, or let me find the y-intercept. 1 equals 3/2 times 4 plus b. 1 equals 3 times 4 is 12 over 2 plus b. 12 over 2 is the same thing as 6. When I subtract 6 from both sides, I find out that negative 5 equals b. Now, because I know the slope of my line, which is 3/2, and I know the y-intercept is negative 5, I can then write the equation y equals 3/2 x minus 5. I'm going to go ahead and graph both of these equations just to make sure that they do in fact look parallel on a coordinate grid. So again, I'm just going to graph both of these to make sure that they look parallel. They should, because they have the same slope and different y-intercepts. I'm going to start with the first one. I'm going to go to +1 on my y-axis, and then I'm going to traverse up 3 and run 2. Connect my 2 points. So that is my first line. My second line is y equals 3/2 x minus 5. So I'm going to start at -5 on the y-axis. Start at -5 on the y-axis, and then from there I'm going to go up 3 and over 2. Do it again, up 3 and over 2. I'm really hoping that my line passes through the point 4, 1, because that's what we need it to do. And you'll look and see here that it does in fact pass through the point 4, 1. And they are parallel. Okay? All right, now let's talk about perpendicular lines. Perpendicular lines, slopes, have a product of -1, meaning if I multiply the slope of one line by the slope of the other line, the solution will be -1. Another way to think about this is that if lines are perpendicular, the slopes are opposite reciprocals. Remember, the slopes are opposite reciprocal. Here's an example. If line 1 has a slope of 4 and line 2 has a slope of, let's see, the opposite reciprocal of 4 is -1/4, then line 1 would be perpendicular to line 2 because the product of their slopes is -1. So let's look at example 1 and see if we can determine if line AB is in fact perpendicular to line CD. So again, we're just using the slope y2 minus y1 over x2 minus x1. So the slope of AB is -1 minus 4 over 5 minus 3. -1 minus 4 is -5. 5 minus 3 is 2. So line AB has a slope of -5/2. Line CD slope is 4 minus 2 over 3 plus 2. 4 minus 2 is 2. 3 plus 2 is 5. If you look at these two slopes, you'll see that they are opposite reciprocals, but we can check it by multiplying the two of them together. And they do, in fact, have a product of -1. 2, I need to solve both equations. I need to solve both equations for y. I need to write y equals mx plus b for both of these equations. So that's what I'm going to do for number 2. So I have 3x plus 6y equals 12. I'm going to subtract 3x from both sides. Subtracting 3x gives me 6y equals -3x plus 12. Divide every single term by 6, and I find out that y equals 1/2 x plus 2. I'm looking for the slope, which is -1/2 x. That's what I'm trying to find. Let's look at the next equation, 2x minus y equals 8. I'm going to subtract 2x from both sides. I have negative y equals negative 2x plus 8. Remember, do not drop that negative on your y. We don't solve for negative y, so here I'm going to multiply every single term by negative 1. Doing that lets me find y equals 2x. Oh, mistake, Mrs. Bischoff, 2x minus 8. But that's not important. I'm really just looking for the slope. The slope is 2. Negative 1/2 times 2 is in fact negative 1. So yes, those two lines are perpendicular. Here I have an example that is asking me if the lines are parallel, perpendicular, or neither. If they're parallel, I know that their slopes will be the same. If they are perpendicular, I know that their slopes will be opposite reciprocals. And if they're neither, it just means that their slopes will be different. Okay? In order to do this, I need to make sure that every equation models the form y equals mx plus b. So I have to solve all of these equations in y equals mx plus b, or put them all into slope-intercept form. So that's what I'm going to do here. I'm going to write all of these in slope-intercept form. So example 1, I have 6y plus x equals 7. I'm going to subtract x from both sides. Subtracting x from both sides, I have 6y equals negative x plus 7. Divide every single term by 6. And I have y equals negative 1 over 6, x plus 7 over 6. Again, the important thing here is the slope, negative 1 over 6. Now let's find the slope of the second equation. 16 equals negative 5y minus x. I'm going to add 5y to both sides. So then I have 5y plus 16 equals a negative x. And then I will subtract 16 from both sides. 5y equals negative x minus 16. Divide every single term by 5. Y equals negative 1/5 x minus 16/5. Here, the slope of this line is negative 1/5. They are not parallel because they are not the same. They are not perpendicular because they are not either opposite reciprocals. So these two lines are neither. They are neither parallel nor perpendicular. The last example that I'm going to do is example 2. I'm going to find the equation of a line that is perpendicular to the equation 3x minus 2 equals 9, but that passes through or contains the point 3, negative 5. Again, the first thing I have to do is find the slope, and I do that by writing the equation in the form y equals mx plus b. So I will subtract 3x from both sides. In doing so, I have negative 2y equals negative 3x plus 9. Divide every single term by negative 2, and that leaves me with y equals 3/2 x minus 9/2. So the original equation has a slope of 3/2 x. Sorry, it has a slope of 3/2. If I want to find a line that is perpendicular to this line, so if I want to find a line that is perpendicular to this line with a slope of 3/2, I know that the perpendicular line will have a slope of, the line that's perpendicular to 3/2 will have a slope of negative 2 over 3. Okay, and I also know the point that it passes through. It passes through the point 3, negative 5. It passes through the point 3, negative 5. So I am going to substitute in negative 5 for y. I'm going to substitute in negative 2/3 for x. Sorry, I'm going to substitute in negative 2/3 for slope. I'm going to substitute in 3 for my x. Negative 2/3 times 3 is just negative 2. Add 2 to both sides, and I find out that b equals 7. And that's it. That's all you do.